matter and change. Yeah. So here it is, everyone. The very first topic that we are going to learn today is chemical reactions. There is one very important thing, like there is one, um, how do I say, one main, so one main discussion in chemical reaction, everyone. So in chemical reaction, we have a kind of rule. It is quite similar to the mass of, law of conservation of mass, which is the molecules before the reaction must be the same or must be equal with the molecule after the reactions. So, for example, before the reaction, you are going to react, for example, two hydrogens and then two oxygens. For example, in the end of the reaction, you must have, okay, um, two hydrogens and two oxygens as well. Or let me make it, wait a moment. All right. Let me make it with a more real example. For example, I want to react two hydrogen atoms. FYI that hydrogen it is active as diatomic molecule in our nature, so it is not 2H, but it is H2. Yeah, plus O2. When we react them together, we will get the result, which is H2O. But as you can see here, in the reactants, we have two hydrogens, yes, two hydrogens and two oxygens. But in the product, everyone, as you can see, there are only two hydrogens and one oxygen only, which is not similar at all, isn't it? So we need to make them balance. We need to make reactants and products have similar number of atoms. Yeah. So I will not teach you about how do you need to balance a reaction because it is not required for now. But I will show you. Okay. I will show you the result of the balancing reaction. Now, if you see this reaction, everyone, reactant now we still have two hydrogens, isn't it? Like, even though the number is here, okay, after hydrogen, but still we need to consider this number, right? So we have two hydrogens in the reactant and in the product, look, when the number is after the element, okay, this number must belong to the element in front of it. So it doesn't belong to oxygen, yeah? It doesn't belong to oxygen, but it belongs to hydrogen. Okay? So now let's continue with oxygen in the reactant. Reactant is in the left side before the reaction, before the O. So in the reactant, we have two oxygens previously. Right? Since this number is after oxygen, so this belongs to oxygen. But you have to consider the number before the molecule, which is a half. You need to multiply the number in front of the element and after the element. So a half times 2 equals 1. So in the reactant, we have one oxygen only. Yeah. Now, let's look at the product after the reaction, everyone. There is only one oxygen, isn't it? So, we can conclude that the number of oxygen before and after the reaction is the same. So, we can say that this is a balanced reaction. This is a correct equation, yeah? Um, Let me write it here. Okay. The number of atoms before and after the reaction or xn it means reaction, yeah, remains unchanged. All right. So like this. Okay. Now we are going to apply this knowledge to the other, um, I mean, to the past paper questions. Everyone, I guess I need to the other room here because it is very noisy out here. Please wait for 1 minute. Thank you. Okay, let's continue. I guess it is more silent here. So let's use the knowledge that I have just told you about the chemical reaction to the past paper equation. So this question number 15, everyone. Look, molecules are simply atoms that join together in fixed and consistent ratios, and that the identities of the atoms do not change during a reaction. So this is another rule, yeah. Not the rule, but actually this is a complete version of the rules. The question is, which reaction may occur in the beaker? Well, according to this question, everyone, the atoms, um, which, well, wait a moment. Okay, the atoms in the reaction, everyone, they are represented by color. So not by the name of the atom or the symbol of the atom itself, but they are represented by their color, by different color. So different atom has different color here. Yeah. So for example, the atom which color is green, it is different from atom with color blue. So um, we have to use these color differences in order to determine which reaction is correct. Okay, and remember, the identities of atoms do not change during a reaction, and the number of atoms before and after reaction remain unchanged. Well, in the bigger glass, maybe probably you will see like there are three green atoms, then two blue atoms, and also one red atom. Well, what can ask us to do is we may use this number of inside this bigger glass, everyone, but please be more focused on the options itself, on the choices that you have. Yeah, it is a very simple question, everyone. You only need to determine which reaction has the same number of atoms before and after the reaction. Look at the options one by one. So option A, for example, look, in reactant or before the reaction, we have two green and one, and after reaction, one green. Obviously incorrect. Thank you, Ali, for answering this question. Yes, the answer is C, but I want to show you why the others are incorrect. Yeah. In B, before the reaction, three greens, but after there is no green. Obviously incorrect. Option C, before the reaction, two greens, after the reaction, two greens, isn't it? So yes, for green it is correct. What about red? Before the reaction, one red and one blue. After the reaction, one red and one blue. So obviously option C is the correct one. Yeah. So yeah, Ali, thank you so much. I believe you already understand about this. Inshallah. So let me move to the next question. Question number 16. Okay. All right. So in question number 16, solutions of drain cleaner, milk, soda pop, and battery acid. Each of them is symbolized by the number connected to pH meters on the diagrams are shown above. Actually, it should be below. Yeah, I replaced this due to inconvenience of space. Which of these solutions can be used to neutralize vinegar? So, everyone, it is about acid and base concept. Yeah. Well, have you learned about acid and base already? Oh, thank you, Naumika, for the answer. Have you learned about it already, acids and base? Yes. All right. So that's great then. Well, acid. If we are talking about the pH of acid, I will write it down here. Okay, for acid, the pH must be lower than 7, isn't it? As for a base, the pH must be higher than 7. And then the question is to neutralize vinegar. Vinegar is an acid. It is a very common acid, asam cuka, right? So in order to neutralize acid, we need to choose one substance which is a base. So, among the four substances, the only one which is a basic solution is this because the pH is 12.63, which is a basic solution, isn't it? As for the others, look, 1, 2.5, 6.5, all of them are acid. So, the correct answer is A. Thank you, Naumika. It's that we can continue to the next question. Nah, look, we have three reactions here, okay? And some compounds are missing. Compound X, Y, and Z are missing. The question, which of the following is represented by letter Z in the given consecutive questions above? Well, it looks like, the question looks a bit complicated, but actually it is very easy and very simple. Well, you need to do or you need to solve the equation like one by one. All right. So starting from the very first equation, I will just write equation one, equation two, and equation three. Okay. So in equation A, in the reactant we have CaCO3. In the product, we have CO2. So we can conclude that X, yeah, X here is actually the rest of the element, the leftover elements. Yeah. So let me rewrite it here. CaCO3 becomes X plus CO2. And then here we have 3C becomes CO. Then we also have 2H2O becomes G plus CaOH2. Now, everyone, let's work with X. Okay. So, if in the product we already have CO2, in your opinion, what elements left in this reaction? CaO, that's right. We do not have Ca yet, and we already use CO2, so one oxygen left. So the identity of X is CaO. I will rewrite it into the second reaction. So CaO plus 3C becomes plus CO. What is the identity of Y, everyone? Yes, thank you. Ca, look, one Ca left, right? And then oxygen is already being used. I'm not, okay, Ali, you wrote Ca. Oh, okay, okay, thank you for correcting that one. Yes, remember the number of the element must be written after the element. Probably you ever see 2H2O. Okay, for example, 2H2O here. Why there is a number in front of the element? Well, the number in front of the element, it belongs to all elements after it. Yeah. So it belongs to everything after it. But if the number is, and the number belongs only for only to one element, okay, it must be written after the element itself. Yeah. So for example, in here, 2H2O, 2 in front of hydrogen, it belongs to both hydrogen and oxygen. But 2 as a subscript here, after hydrogen, it belongs to hydrogen only. Yeah. So yes, only one carbon, and we have two sorry, one calcium and we have two carbons. So the identity of Y is CaC2. I will rewrite it here. CaC2 plus 2H2O becomes Z plus CaOH2. Everyone, before you answer this question, probably, look, there is another thing here. There is another pattern here. OH in the bracket and 2 after it. So this number after the bracket, it belongs to all elements inside the bracket. So as the conclusion, we have two oxygens and two hydrogens in the product. So can you please give me the identity of Z? What's the identity of Z? Yes, thank you, Naumika. It is C2H2. Yeah. So you just need to count the rest of the elements, okay, which is not being used yet. Okay, Ali, please remember, yeah, if the number only belongs to one element, so please write it after the element. Yes, C2H2 instead of 2CH2. If you write it like this, Ali, for example, 2CH2, it means that number two here, okay, it belongs to carbon and hydrogen. Yeah. No worries, Ali. All right. Let me move to the next question, which is question number 18. Since you have learned about acid and base, I believe this question is not will not be a big deal for you as well. So here is the question. Litmus paper is an indicator used in chemistry. It is used to distinguish between acids and bases in solution. Now, I want to ask you, everyone, what color will be indicated by litmus paper when the solution is acid? What is the color for acid? Red, that's right. Base, it is blue, yeah? So we can say that X solution on the right side, on the right side, it is basic solution, isn't it? So let me write base here. And then solution Y, since the color of the litmus paper is red, I can say that it is acid. As for the solution, as you can see, the color of litmus paper before and after dipping into the solution remain unchanged. Means that it is neither acid nor base. So we can conclude that it is a neutral solution. Okay. By using this knowledge, we need to determine which of these five statements are correct. Let's look at statement one. X solution, the basic one, should be stored in glass, and Y solution, the acid one, should be stored in metal container. Well, X should be stored in glass. It is correct, but the next statement, which is Y solution should be stored in metal container. Y solution is acid, everyone. The acid is corrosive. When you put a drop of acid into a metal, well, there is a big possibility that you will make a hole on that metal. So it is that corrosive, everyone. It is very destructive. So it is impossible to store acid in a metal container. Well, the container must be the not reactive ones. For example, glass. Okay. So statement one is incorrect. Okay. Both acid and bases must be stored in glass. As for base, it can be stored in the plastic. Yeah. Like what we have in our lab. Because base is not as dangerous as acid, not as corrosive as acid. Yeah. Now, statement two. Y solution reacts with X and Z solution to form water and salt. Well, it is called as when acid and base react together, it is called as neutralization, everyone. And then the product will be, let me write it down here, acid. Okay, you're quite fast. Thank you for the answer. Acid plus base. They will react together to form salt and not N but plus water. Okay. So in terms of Y reacts with X will form water and salt, it is correct. But it is incorrect with Z. Neutral solution when reacts with acid, it will not produce water. Okay. So option, statement two is incorrect. Statement three, X solution is rich with OH ions. As you know, I believe base contains OH ion, acid contains H plus ion. So yes, statement three is correct. What was statement four? If enough Z solution is added to Y solution, the litmus paper may turn orange. So the statement asks us whether the solution will be neutral or not, right? Well, look, this solution is neutral. Why is acid? When neutral solution is being added into acid, it will not be neutral, everyone. It will be acid, yeah? So statement four is incorrect. Statement five, a result similar to solution Y, which is acid, is observed when litmus paper is dipped in lemon juice. It is obviously correct because lemon juice is acid as well. So thank you, Ali. Yes, it is C. I mean the answer. Yeah. Probably I can continue to question number 19. Which of the following chemical reactions is balanced correctly? Excuse me. So I will leave it to you, everyone. Yeah. All right. So please try to count the number of each element in each reaction. Remember, the number of elements in reactants and products must be the same. So, which one you think is the correct answer for question number 19, everyone? Okay, now Mika says B. Let's look at B only then. Okay, in B, for CO2, here we have four carbon, yeah? And then we have two oxygens, but since we have four as the number here, so 2 times 4 becomes 8. Oh, apologize. Okay, here it is. Okay, let me restart from here. So we have four carbons and 4 times 2 becomes 8 oxygen. Well, in the next one, we have 6 times 2 becomes 12 hydrogen and 6 oxygen. Well, we can combine these two oxygens, yeah, becomes 14, isn't it? So we have in the reactant, we have 4 carbons, 12 hydrogens, and 14 oxygens. And then in the product, look, okay, we have 2 times 2 becomes 4 carbons, right? And then 2 times 6 becomes 12 hydrogen. And also 7 times 2 becomes 14 oxygen. And the numbers are the same as the number of atoms in the reactant. So yes, thank you so much for your answers, everyone. Option D is the correct answer. Yeah. So you only need to be careful in counting the atoms in this kind of questions. Yeah. Okay, so that's for the chemical reactions. I hope the questions in your final will be yeah quite similar with this chemical reaction. It is quite easier from the atom one, right? So let's continue to the energy and phases. Um, I am not sure if you have learned about this in science, physics or not, because I believe that it should belongs to physics, isn't it? The fusion reaction. But yeah, let's try to discuss it a little bit in terms of chemistry in here. Well, the sun manages to keep shining over time by generating energy through a subtle chain of fusion reaction. These reactions involve the combination of four protons, okay, to form a nucleus of a specific element which releases energy. Okay, yes, thank you. It's quite vast. I believe you have learned about it in physics, isn't it? Yeah, everyone. For protons in here, proton that it means is the hydrogen. Yeah. In fusion reaction, please remember that for hydrogens, okay, if I'm not mistaken, it should be like this. For hydrogens, they will combine together to form helium atom and, well, electron plus energy. So, as a conclusion in here, the protons, okay, will react to form helium, okay, and energy in this fusion reaction. So, yes, the answer is D. Let me continue to question number 21. Which lamps give the light when the electrodes are immersed in the solutions in the container? Everyone, please look at the container like one by one and look at the reaction. Okay. Well, how do we know that they will conduct electricity or not? Please remember, as long as there is electron or in terms of the reaction, as long as the product contains ions, okay, it means that the reaction or yeah, the compound will conduct electricity. And since all of this container, all of them contain ions, everyone. So we can say that, eh, wait a moment, ions, I mean in here is the positive and negative ion, yeah? It must be, there must be positive and negative ion. So we can say that the answer is All lamps give light. Okay. Remember, as long as there is iron in the product, yeah. So electricity must exist. Okay. And actually, you can also look at the okay. You can look at the screen as well, the picture as well. As long as there are molecules like free moving molecules, so electricity must exist. But the most important thing is iron. Yeah. Now, let's continue to question number 22. And we are already here in the properties of water, everyone. Yeah. Okay. Well, if we are talking about water, probably in terms of the properties itself, we can try to, imagine the water that we are drinking like every day, for example. Now, question number 22. Considering the properties of water for 10 grams and 100 grams of samples, which of the following statements are correct regarding these samples? Okay, everyone, what I want to tell you first before answering this question is, let's say, for example, 10 grams of water, okay, it is being placed in a glass, yeah. So this is 10 grams of water, for example. And then for the 100 grams of water, okay, it will be placed into a bottle. So this is 100 grams. When the container is different, I believe you can imagine it clearly, inshallah. Everyone, whether the mass of water is 10 grams or 100 grams, or whether the container of water is glass or bottle, they are still water, everyone. So their physical and chemical properties will not change at all. Yeah. So if we are looking at the statement, thank you, Ali, for answering as well. Boiling points are the same. It is impossible for the 10 grams one having a boiling point of, oh, okay, it will boil at 70 degrees Celsius, and then the 100 grams, it will boil at 90 degrees Celsius. It is impossible like that. When the name is still water, when the chemical formula is still H2O, the properties will not change at all. Yeah. And then number two, the densities are different. Density for all waters in all container, in all masses or volumes will be the same. Okay, which is 1 grams over decimeter cube or over meter cube. Anyway, let's see the next one. The volumes are the same. Nah, when the mass is different, obviously the volume must be different. Yeah, so it is A. Thank you for your answer, Ali. That's great. Next, question number 23. Okay, I believe, oh, we still have another. Here, some water, which is not enough to completely dissolve the solid at the bottom, is added to the system in the figure at the same temperature. Yeah. So let's say we have solid A, just any solid. And then when we add like a large amount of water, like a specific amount of water, it is still not enough to dissolve the solid. Like let's imagine when you add sugar into your tea, into your glass of tea, for example. And then there are still some amount of sugar which cannot be dissolved yet. Yeah, that's the analogy, everyone. Okay. Now, regarding the solution above, you need to choose which of these statements is or are correct. It is saturated. Well, the meaning of saturated here, everyone, is that it cannot be dissolved anymore. Yeah. When the solid cannot be dissolved anymore into water, it means that the solution is saturated, everyone. Like in Bahasa, you can call it as pekat. Yeah. So statement one is correct. Why? Because the statement said here, the water is not enough to completely dissolve the solid, which means that there are still some amount of solid remains in the container, isn't it? So statement number one is correct. Statement number two, additional of hot water changes the solubility of A. So what is solubility? Solubility is the ability to dissolve in the water. Okay, it is saying that addition of hot water will changes the solubility of A. In your opinion, okay, in your opinion, when the hot water is being added to the container, do you think that the solid will be dissolved easier or not when there is hot water, everyone? Yes. So the solubility of A or the ability to dissolve for A to dissolve in water is changing, isn't it? So it is correct as well. Now, what about option three? The solubility of A increases. Look, there is no other additional statement. Statement number three, it doesn't change that it will be replaced with hot water or not. It is only saying that the solubility of A increases. So, without any other statement, everyone, when the condition remain unchanged, when the temperature stays same, solubility will not change at all, neither increase. So, statement number three is incorrect. So, the correct ones are number one and number two. Okay, so like this. For this kind of contextual question, okay, it would be better for you to relate it with your daily life. You can try to find some analogies that is very close to you. For example, this phenomena about water and sugar or salt, for example, yeah, to make it easier for you to imagine the question. Next, the next one is about matter and change. So, question number 24. In the realm of highly ordered matter, crystals exhibit a precise and well-structured arrangement of molecules throughout their entire body. Each molecule in a crystal is surrounded by other molecules in a symmetrical and defined manner. The question is, which of the following options are examples of crystalline solid? So, I do not know whether you have learned about it or not, but I have searched a research about this that there are two kind of solids here. Okay, let me write it. There are two kind of solids. The first one is, as you can see in this question, crystalline solid. It is not D, not all of them. Yeah, crystalline solid and not or but and amorphous solid. So what's the difference between crystalline and amorphous solid? Well, crystalline solid, the definition is as you can see here in the question. Or let me give you another information for crystalline solid, everyone. Crystalline solid, the arrangement or mm, how do I say, the structure, okay? It is highly organized. It is very well organized, okay, in a microscopic structure. And most important thing is, well, we can find the 3D version of the crystalline solids more than the amorphous solid. Well, for the amorphous solid, the 3D structure cannot be found. Yeah. Or probably we can say that crystalline solid it is more complex in terms of structure and arrangement. So let's go back to the equation here, everyone. Which of the following options are example of crystalline solid? Well, if we look at these four examples in here, there is one example that's not actually not only one. Yeah. Wait a moment. Oh, my bad. Sorry, Ali. Yes, it is one, two, three, four. Quartz, yes, it is crystalline solid. Diamond, obviously, and sugar. It is also one of the crystalline solid. For table salt, actually, there is a kind of this a bit disagreement for me regarding to this, but yeah, since there is no two, three, four options in here, so we can say that all of them are correct. Yeah. So let's just say for now that one, two, three, four is correct. Even though I'm not pretty sure for the table salt one because it is very, very simple, like an ACL. But it's okay. Let's follow this equation anyway, yeah? So yes, it is D. Next, number 25. Sodium chloride, commonly known as salt, is an ionic compound with the chemical formula NaCl. It is one of the most abundant minerals on Earth and an essential nutrient for many animals and plants. Question: when is the sodium chloride able to conduct electricity? So, sodium chloride it is being formed from the combination of sodium and chlorine ions. So, sodium ions and chlorine ions, they combine together to form an ACl. Now, again, you can use the analogy of table salt at your home. Does it conduct electricity or not? And the answer is when it is a salt, it doesn't conduct electricity. Just let's imagine everyone. You consume you use table salt for example for like you store it in a solid and then at one time without realizing like it is being activated or something by an electricity and then suddenly you get electricized or I do not really know the term. Well, it is very unsafe, right, to store it in a solid state. So, solid sodium chloride or solid ionic compound, it doesn't conduct electricity, but it will conduct electricity when you melt it down. When you melt sodium chloride, of course, it becomes liquid, isn't it? Or when you dissolve it into water. It is different, yeah, between liquid state and when you dissolve in water. When you dissolve in water, you are simply adding sodium chloride or the table salt into the water. But when you turn it into, let's say, liquid state, you do not need the help of water at all. So the answer is two and three only. Yeah. The last one, number 26. All right, we have four. Actually, these are two pictures, yeah, everyone. In picture one, the difference between picture one and picture Two is the temperature. Okay. Equal mass of water and olive oil as are heated in identical heaters for 5 minutes. Why did they reach different temperature after a while, although they were at the same temperature at the beginning? So look, everyone, for the water, okay, the left one is before the heating process, and the after is after the heating process. The same for olive oil. But well, they have a kind of of difference, okay? After the heating process, the temperature of olive oil is higher than water. Now you have to analyze what's the reason behind that. Okay. A, because water is denser than olive oil. B, because the specific heat of water is lower. C, since the energy consumed to increase 1 gram of olive oil by 1 degree Celsius is lower. Or C, the thermometer measuring the temperature of water may be defective or cannot work pretty well. Everyone, I want you to answer this question. Let's try to analyze which one is the most possible answer. Okay, you say A. Look, because water is denser than olive oil. Dense. The word dense here means, well, again, we can say pekat. Well, let's imagine the structure or the water and the olive oil. When you compare water and olive oil, water is lighter, isn't it? Like it is not sticky at all. As for olive oil, it is kind of, slippery, sticky on our hands. It means that it is denser than water. Yeah. So option A is incorrect because it is the reverse. Olive oil is denser than water. Okay. Well, you said C, since the energy consumed to increase 1 gram of olive oil by 1 degree Celsius is lower. When the energy is lower, it will not get, um, you know, it will not get hotter easily. Do you understand this one? Like when the energy consumed is lower, when the energy being used is lower, it will not be easily to, well, be heated up. Okay. The correct answer here is B, because the specific heat of water is lower than olive oil. So it will not get heated up that easily if we compare with olive oil. So the correct answer is B. Okay. Well, for this kind of topics, everyone, I hope I do not know whether it is possible or not to get it, but I really hope you have the the materials that you need for this topic, yeah, because most probably the questions for each series, like for each year in this competition, may be different. If we are looking to the past papers, yeah, there is no 100% same questions in here. Like for example, one time they were asking about solid, the other time about salt in here, and then the other time also about comparison between water and olive oil. So please be prepared with all possible questions. Okay. And yeah, I believe that the past paper questions has finished in here. But in case if I got more or extra questions from either Pa Afta or Miss Sharifa, I'll make sure to inform you about that as well. Okay. Thank you so much for your attention. I wish you nothing but good luck for your competition. Yeah. Thank you so much. You may leave this room and wassalamualaikum warahmatullahi wabarakatuh. Good luck.